I'm Marco. I work at Protocol Labs, and today I'm going to present something that we've been working on for the last couple months that is a very practical tool for us to let anyone find where some content is stored on the Filecoin network. So I'll get it. There's a lot of jargon there. I'll break it down. But the thing I'm presenting is this distributed database for finding content. You can think of content as having an ID. You hash it, and you get this string. And I just want to answer, given this string, who has this data that hashes this string? So let's start with the actual problem that we're solving. Maybe this can give some context of why this is even desired. So we have Filecoin. This is a blockchain using proof of storage, and you can incentivize storage on the network. So you can store data on the network and pay someone to store that for you. We have a lot of data there right now. It's growing every day. I actually had to update this slide today by almost 10 petabytes. And yeah, I mean, we're going to have even more data in the future. So we're going to have a lot of these CIDs, these content identifiers. And so how do we keep track of who's storing what? Well, the first thing we think, it's well, IPFS does this, right? Can we just put it all in the DHT? Right now, the DHT isn't quite ready for this number of CIDs to store. It would be a big ask of each DHT node to just store hundreds of gigs of data. But I think there's definitely some interesting work that can be done here to improve this. And it's still an open question what it could look like, because maybe you could have heterogeneous nodes on the DHT, some bigger machines, right? And you have many small machines that are just kind of in people's closets, and a couple really beefy machines in data centers. But you end up with a lot of trade-offs here. How do you know these machines are good? They could be creating a Sybil attack. Open question. So what if we create our own federated network of nodes, right? We know these nodes. We can trust them. They can be really beefy machines, and they can do this mapping. Well, that's what Storetheindex is. It's just a federated set of nodes that keep track of this mapping of CID to data, or to the content that is referenced by that CID. So I think an illustration kind of helps. And let's see how big that is. Maybe I can make that a little bigger. So this is some user. They ask IPFS, hey, I want some data that's referenced by this CID. IPFS asks, Storetheindex, or this indexer network. And the indexer network keeps this mapping within the network, but it gets the data for this mapping from storage providers who publish something called an ad chain. And we pull that in, and we index that data. And I'll go a little bit deeper into each one of these things. But this is the high-level overview and what it looks like from both the storage provider side and the user side. So this is an actual example. You can run this. In fact, I ran this to create this, of how you use the indexer service. So in this case, we're contacting a specific indexer, and we're just asking, hey, who has the CID? Where can I find the content referenced by the CID? And these are all the different storage providers that have it. This is their peer IDs. So the next step is how does, what is the data that we're indexing? And we get this data from the storage providers themselves. They publish, you can think of it as this blockchain of advertisements. And each advertisement references the previous advertisement. It looks like this. And each advertisement contains the list of entries, a list of things that this storage provider now provides. So my cat photo, your cat photo, my dog photo, right? And every time they get some more information, they publish a new advertisement and link it to the previous thing. And this is kind of what the type signature looks like. It's pretty straightforward. What this gives us is like sequential history, right? Like a huge problem in databases is like, how do I know what came first? Well, we kind of like push the problem off to the writer side. So like the writers here are the storage providers, and they have to give us this canonical ordering of the history, right? So in this example, A precedes B, which precedes C. We know that the advertisement A happens before B. And this is true no matter what order we get the advertisements themselves in. Another property of this is we have the indexers are eventually consistent. So if they'll never give you wrong data, like flat out wrong, but they'll just give you old data when you query them. And this is a property of getting these sequential histories, because when they're looking at this advertisement chain, they might just look at A, and then they only have the information from the advertisement A, and they might later get C and then realize, oh wait, hang on, I haven't processed B yet, so I need to find B first, and then I can do the rest. So you'll only be outdated, but you won't be flat out wrong. We have like a defined order of how to process these advertisements. And what's cool is like you can imagine we want to spin up a new indexer node. We can just do that. And then eventually it'll just walk through the whole chains of like all the storage providers. And eventually it'll be back in the same state as one that has always been up. And so what does this look like from the storage provider? Well, when it has some new information, it creates this advertisement block. And then it puts it in the chain of blocks, and then it tells anyone who's listening over gossip sub that, hey, here's a new head of my chain. Like here's the new, entry node that you should look into. And then indexers can lazily pull this list. And this pull model is really important. So like another big problem with databases is how do you scale writes? But you can actually kind of also work around this by being very lazy about it, right? So if the database itself is like, well, I'm only going to handle writes when I have capacity. I'm only going to pull data in from sources when I can do this. You get these nice scaling properties where like, oh, if all of a sudden, for whatever reason, 5 p.m. on a Friday is really, really popular for queries, well, you don't do any reads, and you just handle writes. This also allows a new indexer to come up pretty seamlessly. Like it just slowly takes its time. When it finishes walking the chain, it'll be up to date. You do lose this property of reading your writes, but it's expensive to read your writes. It's hard to implement, and it's hard to scale. In this specific problem domain, like out-of-date answers are OK, especially because we can cache things pretty aggressively once we do have an answer. So everything I've talked about is really just like with one node, but this scales well across many nodes. And you can imagine we're actually pretty lucky in this problem space because we're just dealing with hashes. Hashes are pretty uniform. We can spin up another indexer and just give it like a subsection of the hash. And their read load should be the same. They should be uniform. But so the index is just one implementation. And so if another node does something similar here, it like processes the advertisement chain the same way, and it provides this query interface. There's no reason the federation only has to be store the index. Someone could go ahead and write like a Rust implementation or some other implementation or something that just uses like cloud building blocks. That would work fine and could be part of the federation. And yeah, I kind of went over this. Like we get a lot of properties here with hashes that make scaling much easier. The previous role, scaling gets really hard because like your data isn't uniform and you have to think and be very clever with how you shard your data. So what does this do? It gives us like IPFS and Filecoin interop. So IPFS defines like a system of addressing and fetching data, and Filecoin incentivizes storage. Here, the IPFS client can ask the indexer, like, oh, who has this? It knows a storage provider has it, fetches it from the storage provider, and it can get that content directly. And this works today with these special nodes called Hydra boosters, which live on the DHT. And there's these special nodes that can query from other sources to return data faster to anyone who's probing them. And it currently queries store the index. And this is kind of like a stopgap measure, you can imagine, but because no changes are required for the clients, but in the future, clients can just directly ask the indexer. And I kind of made this section here, like, what are some useful takeaways that you can take out of this and apply to your own projects? I think there's like some good patterns here that are helpful to think about when building other systems. So first, replication of sequential linked histories is easy. If I can give you like this linked list and you know for sure that like this event happens before this event, right? It's very easy to replicate this. You don't have to worry about like, oh, actually there's like 2 parallel events. Oh, what does it mean to be like serializable versus linearizable? Well, this is just like the strictest definition you can get. This is a sequential history. One cool thing is in Store the Index, these blocks don't have to be provided by the storage provider themselves. And this is pretty interesting because you can imagine that many indexers all need to get this block of data of the advertisement. And you don't want all these indexers to just always be asking the storage provider. So because everything is content addressed, you also have this nice property where the storage provider can put data into a CDN, and then that CDN can give it to storage providers. And then that CDN also asks, or sorry, the block, the storage provider gives the block to a CDN, and indexers can get the block from the CDN rather than the storage provider. And a CDN can also use the indexers to figure out which storage provider it needs to get the data from. So you end up with this like fun like feedback loop. Another pattern that is definitely helpful to take away is if you can partition things by hashes, you should. It really simplifies the partitioning strategy, but it doesn't always work. So you might have like a case where you have clients and they have invoices. Well, it doesn't really shard very well because some clients will have many more invoices than others. One thing you do want to avoid is this like scatter gather pattern of read queries. It just doesn't scale well because you don't know what the answer is until you've asked everyone, and then you're really just waiting on the slowest link. Okay, so store the index and you. How can you be a part of this? So if you want to make or propose changes, there's a store the index repo. We can start a discussion there. You can reach out to us on Filecoin Slack and store the index channel. And we have a FIP right now, which defines what the spec is of this indexer system. If you want to join the Indexer Federation, that's great. Let's chat. It is pretty storage intensive. It's going to be bandwidth intensive too. Although this is cached pretty readily, you're still going to have to pay for cache misses. Right now, you should be able to provide some decent uptime. I think in the future, with some cleverness, we can reduce this requirement. But yeah. And then let's say you store content address data and you want to tell other people about it. Well, if you're a search provider running Lotus, you can already do this. Otherwise, you might have another system, and you can take a look at this reference index providing implementation. And let us know. I'm happy to unblock you with however we can. And yeah, so here's some useful links. sid.contact is the website of the currently running indexer. And these slides are also on GitHub. And I'll take questions. I'll repeat your question.
How ignorant to Filecoin is this versus being able to use it directly with IPFS?
how anchored to Filecoin directly is this versus being able to use it on IPFS? It's not anchored to Filecoin, so the advertisements themselves, I kind of like. Yeah. So the entries themselves have like information of how to fetch the data. It's not necessarily just like which storage provider has it. It's instructions on how to fetch it. So the instructions could be like connect over BitSwap to this other node, and it's like not even related to Filecoin at all.
Great. So anything emitting content address or the advertisement structure to that.
Exactly. Yeah.
PubSub topic. Mm-hmm. Is that a single PubSub topic, or is it configurable like runtime or application time?
Yeah, it's configurable. Right now we have like a mainnet and a testnet, but I mean anyone can just run the whole set of indexers on a separate PubSub topic.
Thank you.
Mm-hmm.
So 2 questions. The first one is, what do you do if you get 2 competing advertisements for the same previous hash? And the second one would be, what is the incentive structure for running such a node?
Yeah, so the first question is, what do you do if you have 2 different heads, right? Yeah. So that's undefined behavior. It's really, right now, it's implemented as like whatever the indexer last sees is the truth. But like last is a time-based concept, right? So it's basically undefined. If you want your data to be retrievable, then you don't do this. The second bit is, what's the incentive? Yeah, this is a tricky question. So there's a couple of things. One, I mean, I think the simplest kind of answer here is like, well, what's the incentive to like crawl websites and be Google or be a search engine? And you can glean a lot of metadata from this. You also get like a lot of, you're like directly connected to the fire hose of what everyone's providing. So you could even add like a secondary index on content itself, and then do something that's more like Google, where it's like now you can actually index text or whatever.
Hello. So what happens if a storage provider stops providing a content? If the deal runs out, like how does this affect this chain of adverts? And it probably also relates to what you said about CDN. So what if I'm a storage provider, I say, okay, I'll store the data at this CDN, but then after, I don't know, a year, I realize I want to go to another CDN. So I have to change something there. Is that going to mess up the whole history, or how do updates happen?
So I guess there's 2 parts. One is, how do updates happen? Well, these like entries aren't just addition. They could be subtraction, or they could be like a modification event. So like the storage provider could say like, oh, actually, that thing I published previously on the chain, like remove it. I don't provide it anymore. And then what was the second part? Sorry.
About the CDN, I guess it's the same. If I go to a different CDN, I'll have to provide different information into that advertisement.
Yeah, so this doesn't specify like who's, I guess the CDN is kind of like separate in that the CDNs aren't publishing to the indexer.
No, the storage provider does.
Yeah.
Okay, so the storage provider will just have to update that and it's all good.
Yes. Yeah. Okay, I understand your question now. Yeah. So it's just like a modification, like attribute or field.
And the storage provider will have to sign that so that we know that this update is not someone messing about with the data I'm providing. It's just, me updating what happened to the data.
Correct. Yeah. So the whole ad chain is signed by the storage provider. So it's not like another person can like mess with that chain.
Thank you.
Any question? I think it's good.
Cool. Well, thank you all for listening.